So this is the rough agenda. So as I said, there is no real structure. So I'll just start. Okay, so I will first show you a couple of scripts what I use, and then I will talk about the multiple different types of parameters inside Oracle. Right? So there are actually quite a few different types of parameters in Oracle. Okay, and now we go to SQL+. So, welcome. Okay, let's see how to do this. Let's say I just picked a random parameter. And by the way, as the description said, this session is not about explaining what the actual parameters do, all thousands of them, right? It's actually about explaining how parameters work. And you know, there are a few things we need to know about it. So the first thing is, I mean, I'm sure everybody knows this, right? So if you don't know this command, then you might be in the wrong place right now. So, so show parameter. Right. So when anybody asks you, or when in an OCP exam guide or exam, somebody asks you that how do I show Oracle instance parameters, right? What's the way to show Oracle instance parameters? So the first thing which comes into my mind is, hey, show parameter, right? Okay. Or select, you know, value from $, parameter where name equals this, for example, right? So technically, this is the wrong answer. These commands don't show you instance parameters. These show you session parameters. Every session can have their own parameters. So when you enable SQL trace, you would actually see that show parameter command, internally it queries $, parameter, right? And $, parameter shows you session parameters, which may not be the same what the instance level values are. So actually, there is another view. It's not a new one, but it's just an unknown one called $, system parameter. So $, system parameter is actually the one which shows you the instance parameter, instance-wide parameters, right? So basically, when you log on, you will get whatever whatever parameters are in $, system parameter, they are copied to your session, right? But now maybe you have a logon trigger, or some application changes some parameters with alter session, right? Then it will only change here for your session and not in system-wide. So technically, when anybody asks, you know, in the OCP exam or something, that how do you show instance parameters, then the answer is $, system parameter, not $, parameter. And let me show you that. So, you know, when I say alter session set, I pick this random parameter for demo. Let's set it to 66, right? You see, this parameter has changed for me now, right? I changed it in this session, and it's 66. But when I query it in the system-wide, in the instance level, right, obviously it hasn't changed because I did not use alter system. Okay, so the system-wide parameter has not changed. And let me check the session-wide parameter from another session, just, you know, for completeness. I will open a new window and I log in. Right? So in the other session, this parameter is not 66, it's still 0, right? Because this other session, you know, still was copied the system-wide parameter, which was 0. So, I just wanted to, you know, show you that for a start, that, you know, that for years and years, and in the documentation, often, you know, you always saw that just do a show parameter or use $, parameter and you see the system-wide parameters. Actually not. You will only see your own session's parameters. So by the way, when I describe $, parameter, right, you see all this, parameter name and its value and so on, but you don't see it here. You know, $parameter does not allow you to peek inside other sessions parameter values. So I already see there is a question that how do you peek into other session parameter values? So there is a way for that, way for doing that, but I'll get back there, right? So what it really means is that whenever you log on, you know, there is a problem with your report, and now you log on as a DBA, right? Just to see which parameters are in effect. If you say show parameter, or if you query $parameter, you're not seeing what the other session is using, or you're not seeing what the system-wide value is. You only are seeing your own session's values. And if your logon trigger or something has changed something, you will see different values than the system-wide values are. So $parameter and show parameter only show your own session's parameter values, really. Okay, and just to make things more interesting, there is actually a view called $parameter2 and also $system parameter2 as well. So if you wonder what these are, this is another. Let's see if I do show parameter. Let's see if I have. I only have one control file. Let's see if I have anything else. So basically what this parameter2 and system parameter2 are doing is that when you have some parameters which have multiple values, you see, when you have, I only have one control file here, but if you have 3 control files, then $parameter would show you all these 3 files in this line and separated by comma. But $parameter2 would actually show you each value on a separate line. So, and that was useful back in 8.0 days or something, where the $parameter itself, you know, the regular $parameter without the number 2, there used to be a bug that when you had multiple values for a parameter, it only showed you the first one. But then they fixed this bug. So $parameter now shows the values on one line separated by comma, while $parameter2 would return a separate row for each value. Let's see if there are any parameters in $parameter2. Where there is more than one value. Apparently not in my instance. But if you have multiple control files, for example, or you have multiple. Let's actually change this. So I'll just say alter system set user dump test equals this. I'm doing something wrong here. Sorry, I think it was the other way that I gotta put. Sorry, not user dump test. So that's what I meant by saying that there is no structure and no preparation. So trace, not user dump, UTL file there. So this is what I wanted to change. Alter system set equals. Let's set it to these two. Let's see what happens. So I'm actually too lazy right now. I would have to do the restart and so on. That because it's a security feature, we shouldn't change it. But basically, I'm not gonna waste time on it. Basically, if you have multiple values like multiple control files, multiple UTL file there, then $parameter2 would actually show you one row for each. Not that important to know, but if you next time you wonder why is there $parameter and parameter2, then you'll know. Okay, so anyway, so where do we go from here? I'll show you where parameters are kept as well. So that's actually pretty interesting. So SGA_stat just queries $SGA_stat, right? And there is this script called KSMSP, again, which if you want to learn more about this $KSMSP, then view one of the previous hacking sessions about shared pool. This is a fairly heavy script, so it's dangerous for production, but good enough for research, right? So this actually shows us how many chunks of memory are allocated for some specific reason for the shared pool. Okay, so you see we have let's see how many sessions we have logged on right now. Select count star from $session. So that's the rough session count. If you have recursive sessions, then the actual number is bigger, but I don't think we have any right now. All right, so so we have 27. Let's just also check select star from $resource limit. That shows the correct session count. I mean, even if you have recursive sessions. Okay, apparently we do have a bunch of recursive sessions. I guess they're cached. So that's yet another topic. I'm not going to go there. So if you want to learn about recursive sessions, then Google for recursive sessions tunnel podder. They are not shown in $session, and I wrote a script for that. Anyway, so back to the previous topic. Okay, so let me just go back here. I just want to show where they are kept. I don't want to drive it very complex. Okay, so right now I have there is a thing called parameter table. The size is that there is a chunk size. So apparently there are 25 chunks of memory allocated from shared pool for parameter table, and they are 0 to 1 kilobytes in size. And for the same reason, for the parameter table, there are more chunks which are 1 to 2K in size, 250 of them. Let me log on with one more session, and I want to show you what happens. Okay, so now I logged on with one more session. Okay. Okay, you see, previously this value was 25. So now I logged on with one more session, and actually I went from 25 to 28. So let me scroll up. So it used to be 25, right? Now it's and then it went to 28. And there are some a bit bigger chunks which went from 250, total that many bytes, to 280, total that many bytes. So basically what and let me log out again. So I log out from this session, and I also log out from the second session. I had 3 sessions logged on here, now I only have 1. So when I look into the same chunk allocations, you see the number of allocations dropped to 24, right? So basically what this means is that when you log on with a new session, you will have to allocate memory from shared pool for your session. And why would I need to allocate memory for every session for parameters? Well, it's because you may want to change your session values only with alter session, right? You may have 1,000 sessions logged on, and some of them want to have their own values for parameters. So where do they keep them? Well, they keep it in shared pool, right? So I don't know why they keep it in shared pool, in the sense that, you know, in dedicated connection mode, you could actually keep it in private memory as well. But maybe it's just done for so that in case of the multi-threaded server or the shared servers, you can, you know, that all the processes could access that session's parameters. But anyway, so I wanted to show that, you know, when you log on, you will allocate memory from shared pool for parameter values, right? So these are the regular parameters. So I'm not going to talk about the shared pool implications. I think I covered it the last time, but basically, you know, that's another example that why bad connection management is bad. Where, you know, if you create a new connection, you know, you log in and log out for every single query you run. Well, you know, you will have this process startup overhead, but you will also have the shared pool overhead that, you know, you constantly allocate some chunks of memory for your parameters, and then you run your query, and when you log out, you will just free them again. That will also cause shared pool latch contention. But anyway, back to the parameter topic. So as the parameter values live in the shared pool, it's actually possible to view some of them. So, but I will get there. Okay. So far I wanted to show that whenever you run show parameter or use $parameter, you will see your own sessions parameters, right? You're not seeing the system-wide ones, nor or the system-wide default, so to speak, nor somebody else. Okay. So I'll just look into the agenda and see where to go next. Okay, I think the logical next thing is actually to talk about these parameters which we can, you know, which are visible to other sessions as well. So, but I gotta introduce this, so I will do a little example. So I will start with this. That if I change a parameter, then and run some query, and I change the parameter again and run it, why do I have different child cursors? Okay, so let me just log out and log in just to have the default values. Okay, so again, I'll use this just for, I think I used this one, so I use this just for hacking, demoing parameters. All right, so let's run the query. So select demo1 count star from dual. Okay, I just run it a few times, and let's now check what is the hash value of the query. So this little hash script shows me the previously executed query's hash value, right? So this is the SQL ID and this is the child number, right? I run it once more. It's still the same, right? We reused that cursor. Okay, so I can list all child cursors for that SQL ID, and you see we only have one child. You know, child number 0. Even though we soft parsed and executed this 4 times, right? So we still have one child cursor. All right, and now let's do this. I'll just say alter session set optimizer index caching equals 1. You see, it used to be 0, and now I just set it to 1. You know, really minor difference, right? Because the max value is 100, I think. So, and now I will run this query again. I ran the same query again, exactly the same text, you know. The SQL ID is the same. You see, the SQL ID is the same of the last query, but the child number is 1. It used to be 0, now it's 1. And the question is why? So let's just see what's going on here. So if I look into SQL ID, we have child 0 and child 1. So child 0 was parsed and executed 4 times, and child 1 is executed only once. So now you might have the question that why do we have a new child cursor here? So there is a view called $SQL shared cursor for this. It actually exists since 9i or 9.2. And I have written a little script called non-shared, where you pass in the SQL ID and you'll just say that tell me why, I don't remember whether this is needed here, but basically tell me why we have created multiple child cursors. Okay, so child number 0 was created, well, there is no specific problem why it was created, because, you know, it was the first cursor, right? It had to be parsed. But, so this stuff comes from the $SQL shared cursor. So this row here tells me that this child cursor number 1 was created because there was a mismatch between the optimizer settings in my session and in the previous cursor. So basically, whenever I do a soft parse means a library cache lookup. You know, I'm looking up a cursor based on the SQL ID and the text, right? So, and when I find one cursor, for example, then I will examine this cursor, this child cursor. I will examine it and I will check what were the optimizer parameter values which were used for compiling that child cursor. So basically, whatever optimizer parameter values were in effect when you compiled and parsed this child cursor, these values are actually stored together with that child. So the next time when I have changed a parameter value in my session, you know what happened in my case, I changed this parameter value, we looked up this cursor, we found child number 0, but then we saw that, oops, we cannot use it. Because there is at least one optimizer parameter which is different between the cursor and my session, right? And that's why this cursor number 1 was created, because all the previous cursors which we examined, they had an optimizer mismatch, right? And actually, starting from 11.202, there is an XML type field which actually tells us a bit more information as well. It actually tells us which parameter we are talking about. Optimizer index caching. It's actually possible to trace it as well, but that event is too undocumented. Okay. Dean asked that, can I show the contents for non-shared? All my scripts are downloadable, you know, where I mentioned, you know, from my website. So this is actually basically how I format it in this nice way. I used Tom Kite's print tab code. I just customized it a bit, and basically the query what I pass into that is this. Just select from $SQL shared cursor where SQL ID is whatever parameter I pass into it. And the customization is, okay, so the customization is here, that what I added, that I don't print out all columns in this tabular format like Tom's script does, but I only print out these columns where the flag value is not no. So whenever the flag is yes, this means is that this particular reason, this particular column was the reason why this child cursor was created. But anyway, so it's dynamic. So if there are more than one reason, then it shows multiple rows for this query. So for this child cursor, sorry. Okay, but anyway, so this again, I kind of went into library cache topics, but I will have now a sip of Red Bull first. But now I would leave you with the question for a few seconds. That how does Oracle know, or how does Oracle, how did Oracle find out that that this optimizer index caching value was different from my session? I mean, where is this information kept? Or I kind of already mentioned how it's done, but let me have a sip of Red Bull first. My brain is kind of slowing down. It's evening already. Okay, I am back. So Marcus, I see a question. I'll get back to that later on. All right. So how does Oracle know this? So let's look into $SQL. So this is $SQL. So there is one column optimizer env in $SQL. So let's just do this. So select SQL ID, child number, SQL, sorry, where SQL ID equals this. I think we got into you see, I queried from $SQL, right? And now I only have one row. The child number 0 is left. Where is the child number 1? I used to have two lines here. So this is yet another issue what you gotta be aware of when you research things. You see, when you run a query only once, then you pin its memory chunks twice. Because the first time you run the query, which is not in cache at all, the first time you pin its memory chunks for hard parse and for loading the contents in there. And then the second time you pin it in shared mode, you actually execute the cursor, right? But how shared pool works is that if you have pinned a chunk of memory only twice, then Oracle thinks that this is a transient chunk. It thinks that this is only used once. Somebody must be not using bind variables, and I'm not gonna keep this in shared pool for long enough. So this chunk will be in the transient end of the LRU list. Okay, so and this actually affected my demo right now, because let me just go back. You see, I used to have 2 lines here, right? Or 2 child cursor. One child cursor, the number 0, I executed 4 times. But the second I only executed once, right? So these chunks were only pinned twice. And shared pool thought that, hey, this is a transient cursor. It will just flush it out because it's not reused. But the moment you execute it once more, when the chunks are executed, when the chunks are pinned 3 times or more, then Oracle sees that, hey, this query was executed more than once, right? So therefore, it must be something which we want to reuse, and it puts it into the recurrent side of the LRU list. So therefore, it doesn't flush it out as easily. And what happened here is that, you see exactly, we had child number 0 with 4 executions and child number 1 with 1 execution. And this is only pinned twice. Oracle doesn't think it's a frequently used thing. And that's why now when I ran all the other queries here, Oracle just threw out my cursor number 1 because it thought nobody needs it. So let's get back to this. So let me just run this Sorry about this. So let me just run this, three more times. And now when I query the this $v$SQL, I still have child number 0 and child number 1 as well. But now it's parsed and executed multiple times, so it won't get kicked out as easily. All right. Yet another thing which may affect your tests. Okay, and what I wanted to show you is this. So I queried this optimizer environment field. So I could actually scan through. You see, and this is displayed in hex. It's a long value. It probably is longer than 2,000 characters. It was raw data type 2,000 characters. Shown here, but it's probably is longer internally. It's just Oracle doesn't support a raw data type which is longer than 2,000 bytes, right? So it's 2,000 bytes actually, not characters. So because this is shown in hex. So, but you see, it's a long value. So somewhere here there is a difference. And then I look into the hash value here. You see, it's different. So actually, Oracle makes it easier for itself as well that it first compares the hash value. That this is a hash value of all of these optimizer parameter values which were used when you parse the child cursor, right? But you see, from this, if the hash value is different, you immediately know that, hey, some optimizer parameter value in this cursor is different from that other cursor, right? But basically what I wanted to tell you is that, the big news sort of is that when we talk about parameters, then yes, we have instance level parameters which are kept in shared pool. And then we have session level parameters, which are also kept in shared pool. They are the sessions parameters. And then some of these parameters are copied inside each child cursor. So basically, if you have 10,000 child cursors in the library cache, you will actually have 10,000 copies of the optimizer environment values which were in effect when that particular child cursor was compiled. And this is how Oracle knows, when I run the non-shared again. By the way, non-shared is not fully reliable. So in this case, when I recompiled the cursor, this reason code went away. Let me just show. So this is the correct output. So it's a bug. So Oracle hasn't fully figured it out. But basically, this is when you don't hit this bug, you will see this. But basically, that how does Oracle know that there is a mismatch between the existing cursor and my session parameter values? Basically, whenever you do a soft parse and you look up, you walk through the existing cursors. When you find an existing cursor where the SQL ID matches yours and where the SQL text matches yours, then you cannot reuse the cursor just yet. You have to do a bunch of checks, like some authentication checks and stuff like that. Plus also that whether the optimizer parameter values inside that cursor, the previous cursor, whether they match exactly these values in my session, right? And how Oracle does this check, it just compares. It just compares your session level optimizer environment parameters with whatever is stored in that cursor. And now you might ask that, but why on the earth would I want to do that? I mean, why do I have to recompile a new child cursor when I change optimizer parameters? Well, isn't that the point, right? Whenever you change optimizer parameters, you want to make something faster, right? things may go faster because that optimizer parameter forces you to compile a new execution plan, right? You change a parameter because you want a new execution plan or a better one, right? But if you reuse the old cursor, if you reuse the old cursor, you will reuse the old plan, right? You want to have a new plan, right? Therefore, whenever you change optimizer parameters, and if there is not an existing such cursor in cache already, Oracle compiles a new one because you want a new plan, which hopefully is better. So that's why this overhead is needed, and that's why soft parses are pretty expensive. Soft parse is not only just some sort of a hash table lookup by SQL ID. There is much more stuff going on. So basically, every child cursor holds a copy of the optimizer parameters, which were in effect in your session when you compiled that child cursor. And it's used for determining whether we can reuse the old cursor or we should compile a new one. Okay, so Luis, yes, I'm gonna get there as well. So let me look into, so I'm gonna do, we will get back to this topic, we will continue here. But now I will take like a 5-minute detour. Let's look into how many parameters we have. So we have 344 parameters in $parameter. So let's do this. I will just select is basic. So that's just something that appeared in 10G. Not too interesting, but for completeness, I will show that. Group by is basic. So in 10G, they actually, in an attempt to even simplify more, they actually came up with a list of parameters which are kind of the basic parameters. That this is the stuff what you want to configure or may want to configure when you set up the database. But everything else you should leave as it is. So basically, stuff like SGA target and so on, these are the basic ones. So there is a little script called, if you have forgotten about it, there is a little script called HTML what I use for formatting the results into HTML, if it wraps. But basically, these are the basic parameters like the processes, sessions, DB block size, and so on. And in the ideal world, you should not need to set any other parameter ever, right? In the ideal world, okay. But I must say Oracle has done a very good job nowadays. So remember, in Oracle 7.3 and 8.0 and so on, you had to tune a lot of parameters if your instance was big enough. But right now, it actually is pretty pretty well working. Unless you run something like SAP or PeopleSoft, where they really force you to use these parameters, what they have used for their testing, all these little undocumented ones. So, but let's get back. So, okay, so when I do this group by, we have like 344 parameters total. 30 are considered basic, 314 are considered advanced. But these are the documented parameters. If you want to actually see all the undocumented ones as well, then we should look into $KSPPI. Because I mean, the $KSPPI includes the basic parameters. I mean, it includes the basic documented ones, advanced documented ones, and also all undocumented ones. And undocumented ones are the ones which begin with an underscore, right? You see, again, a way to research this. I mean, how do I know this stuff, right? So I've researched it. So I have a little script called v, which shows me, it uses $v fixed view definition view, and it shows me the contents of $v views. So, and let's see what $v parameter does, right? So here is a condition which says this. So this condition here is the one which filters out all undocumented parameters. So you see, it looks into underscore. So whenever there is a first underscore, whenever the parameter name starts with an underscore, then it will filter it out. So in reality, in this version 11.202, we have that many parameters. In 11.203, we have 2,800 or something. Well, even more. So we are going to reach 3,000 parameters soon. Okay. So and then now there is a question that what is the $KSPPI? Is it a session or system-wide parameter? So $KSPPI is actually this is just where the parameter names are stored, and this is where the values are stored. So KSP means kernel service parameter something, and CV means current value. So this is the current value in the session. So it's the session value. But if I look into the $V system parameter, then you see $V system parameter uses KSPP SV, which is the system value. Again, you know, I'm not, so just look into how the script called V works. So you know, you can peek inside $V views yourself. That's one way how I research things, right? You look into where do these values actually come from. And, well, I already had forgotten about this. You see, system parameter 3 and 4. So let's see, what do they do? So this comes from the system values 2. You see, this query is without any further restrictions. Let's see, what do we have here? I doubt that these are even documented. So display value. Yeah, I don't know what they are right now. But again, you know, another example that how when you navigate around in $V views of Oracle, you'll see new things. So let's just check $V system parameter 3. Let's search for so I'm just going to the documentation. So let's go to $S. That's where it should be. Oh man, so $V system parameter 2 is there, it's documented, but 3 and 4, I think, you know, they are not, right? So lots of undocumented things going on in Oracle, even if the view is a $V. If I really want to know, I don't spend time on it right now, but if I wanted to know what exactly is this view doing, well, I don't have to guess. I don't have to guess because I see exactly what is the difference from the query, right? So system parameter 2 does this. It shows some sort of, you know, decodes some column value bits here and shows some trues and falses and so on. But this just you know, shows the raw values. But anyway, so that's not where I wanted to go. I wanted to talk about different things, a bit higher level things. Simon just joined and asked whether there is a way to watch the replay later on, and yes, so I'm actually recording it right now, and I hope to upload it today. So I'll blog where it is. Okay, so we had a little. So basically, where I was getting at is that at the parameters, all the undocumented parameters, we have 2,600 of them in this version of Oracle, and the value is the number of the parameters is getting closer to 3,000. And maybe in a couple of years we will have 5,000 or something like that. So it's quite a lot, right? It's actually quite a lot to keep in memory. I have a little script called PD. Which shows me, that's actually a trivial script, a simple script. The whole internet is full of such scripts, right? But I just wanted to show you what I use every day when I deal with checking these parameter values. So again, this script uses these X dollars. So therefore, you gotta run it as sys, right? Because non-sys users usually can't access X dollars. And you see, it has shown me 2 documented parameters and 1 undocumented parameter. And the cool thing is that this X dollar here, it actually has a description column. So whenever you see a new parameter, you can just run PD with its name and you see what does it mean. Of course, it's just one sentence, but in many cases, it's enough to understand what does it mean. If that's not enough, then I take the parameter name and I put it to MetaLink. And I search in my Oracle support, and I search in bug descriptions as well, because then sometimes I find what they mean. All right. And by the way, I'm not advocating that you should start changing every single parameter here, right? So it's not what this class is about. It's about explaining how parameters work and hopefully explaining how why some weird things are happening in Oracle related to cursors and recompilation. Anyway, so I can use percentage here, which would show me all the parameters. Right? For every single parameter, we have the name, its current value in the session level, and the explanation. So that's really like a gold mine. So, and now back to this topic back to the topic of recompilation of the cursors. So let's see where it was. Okay, apparently the cursor number 0 has been aged out now. You see, only 1 is left. So, because the 0, I used the cursor 1 later. So if I want to create one more cursor, I can just say alter session set optimizer index caching equals 5 or whatever different value than any of the previously cached cursors have. I run the same query again. So where did it go? All right. And now again, I have 2 cursors. Okay. So 2 child cursors. So now if we have 2,600 parameters, we have over 2,000 parameters. It would be pretty expensive to store all of them in every child cursor, right? So actually Oracle guys have realized it, and they actually have split the parameters into 2. Or it's actually not correct to say that they have split anything, but there is so it's actually technically right to say that the parameters what are stored inside the child cursors, they are actually completely different parameters. Physically they are different parameters, but they actually have different numbers and so on internally, but they just happen to have same names mostly. So basically where I'm getting at is that there are actually parameters stored inside child cursors which don't exist as regular parameters, and I'm going to show you how to kind of measure that. But basically, one of the reasons is that there are plenty of parameters like processes and sessions and transactions, SGA target and stuff like that. And these parameters are not optimizer parameters. They don't have anything to do with optimizer, and they don't. Some of them don't change anyway, right? So it doesn't make sense, or there is no need to put all of these 3,000 parameters into each cursor. It makes only sense to put the optimizer related parameters into inside the cursor, right? So, and actually starting from some version, somewhere in 10G, I would suspect, 10.2 perhaps, we have new views called $SQL. Sorry, let's start. By the way, there is a script called D, which just shows me data dictionary views when I have forgotten what's the exact view name. You don't need to open up the documentation every time you have forgotten a view name. You still remember parts of that. And basically, starting from 10.2, unless if I'm not mistaken, we have these kind of views called $V something optimizer env. So this is the optimizer environment. So this is basically the bunch of parameters which affect the execution plan. And these are, whatever is listed here, these are the parameters which are stored inside each child cursor. So you see, this query returns only 47 parameters. This query tells that there are only 47 parameters which are part of optimizer environment. Again, that's not the full truth, because this view only shows us the documented optimizer parameters. So, so by the way, you can run the HTML script like that as well, if you expect it to be too wide for the screen. So the documented optimizer parameters are listed here. For example, like parallel execution enabled, optimizer features enabled, and stuff like that, right? You see the current value, you see the default value. What's the default value? And by the way, there is a view called is default or not. If this parameter has been changed, in the init aura, because this is the system-wide one, then the is default column here is no. So you can actually find out which columns are not default, or which parameters are not default at the system-wide. Okay. So it only shows us 47 rows. But you see, there is a column called ID. It kind of shows that there are, the last parameter, 47th one displayed actually has some sort of an internal ID 290. So actually, if I want to see the full picture, I should actually find out what is the $X table where these values come from, or where these rows come from, and query that $X. So basically, what I usually do when I research this kind of new views, I just look into $V fixed view definition and see what does it show. So basically, this is this $GV sys optimizer env, and this is the view text, right? So, and you see it actually selects from this $X. So it's some query compilation, whatever, compile environment or some compilation environment. And you see there is a where clause where we have these kind of conditions. And these are the ones which now filter out, things which are like undocumented parameters and so on. So if I want to see all of the optimizer environment values, I gotta query this $X directly. And that's why I have written a script called sysopt. System optimizer environment. So this is the instance-wide optimizer environment. And I can just say percentage here just lists me every parameter which is part of that environment. So you see, actually we have 313 parameters which are part of the optimizer environment in this version. So every single child cursor has values for 313 parameters stored in it, right? Some values, I mean, some things don't take a lot of space actually, because this is just true or false, right? I don't know, maybe it takes only 1 bit, maybe they have optimized it that well, maybe it takes a byte somewhere, but it's not like every parameter takes 100 bytes or something. All parameters tend to take only very little space. Okay, and 300 parameters is still better than 2,600, when you store it in that much of data in every child cursor. So whatever parameters are listed here, these are the ones which Oracle checks when you soft parse a cursor. Oracle will go into library cache and find whether there is an existing child cursor, and when it finds an existing child cursor, then it will check all of this, then it will compare all of these 313 parameters and their values, right? And if all of these values match, then it will reuse the existing child cursor. But even if one single cursor, even if a single parameter value is different, then it will compile a new child cursor. And the $v non-shared, and the non-shared script should show me the reason why a new one was compiled. Okay, so there are different parameters. So let me just quickly show you this once more. So the optimizer n, so for every SQL cursor, this bunch of bytes, this is actually what stores these particular parameter values for every child cursor. So, okay, so basically let me just look into the GV one. So when I look into this optimizer environment views, so there are actually 3 views here. Sys optimizer environment shows me the system-wide values, right? Sys optimizer environment shows me the session-wide values, or session-level values. See, when I describe it, there is a seed as well. So this is the view which allows me to look inside another session and see the parameter values for that other session. So I'm logging on with a new session, and let's alter session set optimizer index caching equals 33. Okay. Now I can query this view to see the values of another session, because when in this first session, when I say show parameter or query $v parameter, then I will see my own session's values, right? But I want to see this other session. So, and I've written a little script called sesopt. Just like we have a sysopt, we have sesopt, which takes the seed as a parameter. So this second session is, is 33. Okay, sorry, the second session seed is 31, 35 here, right? So I'll say this, and I don't want to see all of the parameters. I will say show me only the parameters which have optimizer index in them. Okay, so right now I went into shared pool and I looked into that other session's optimizer environment parameter values, right? And you see there is one parameter, optimizer index cost adjustment, which is default. It's still default. I haven't changed it from its original value. It's 100, and the optimizer index caching is where the value is not default anymore, and the current value is 33. So basically, this is the way to look into another session But this only shows you these 300 something parameter values which are part of the optimizer environment. So you cannot, let me show everything, right? So you cannot look into other parameter values. But that's good enough for start, because when you wanna the main reason why you would want to see some other sessions parameter values is some query execution plan issue, right? And this is when you want to see optimizer environment values anyway. But yeah, if I use percentage here, then I see all the 312 values. Okay, so, and by the way, this script what I used, you see, this is the seed. It uses this in clause. I can do this as well, that instead of looking into one session only, I can look into select seed from $session, and maybe add like where username is something or whatever I want, and maybe look into optimizer index parameters only. So basically, when I do this, you see parameter 1 will be replaced by this. So this select seed from $session will be actually moved in here, right? And it will become like a subquery. So this allows me to list, like, show me all sessions and only that parameter value for all sessions. One more reason why do you use SQL Plus and scripts like that, it can be very flexible. And I can immediately see that, hey, there are 2 sessions where this value is not default, right? Seed 631 and seed this, and I see their values. Sometimes I might want to see, who else has set the values in some login trigger or in application, right? If it's a login trigger, it's easy because you, as a DBA, you can look inside this, login trigger text. But if the application itself in the Java code alters these parameters, then the DBA doesn't have control over it, other than removing the alter session privilege. Martin asked that, isn't this data visible in $SES optimizer environment? Yes, Martin. So this is this data what you see here is also visible in this $view, but the $view only shows you the documented, 47 documented optimizer parameters. But the underlying $, what I use in my script, this $, one, this shows me the undocumented optimizer environment as well. And when I diagnose or troubleshoot something, I want to see both, because often somebody has read an article in internet and has changed an undocumented parameter, right? So the $, shows me everything. Okay. So this is what the optimizer environment is. And now, when I researched this, then so Luis, yes, the views only show documented parameters. So when it's a SUS optimizer environment or SES optimizer environment, they only show the documented ones. Just do the count star from both in your test database and you see the difference. The $, will return much more rows. And there is a third one. So when I go back to this, there is a third one. $SQL optimizer environment. And that's very interesting because, when you query the optimizer environment like this, this is the binary representation. I don't know how to read this, right? I could start reverse engineering this or whatever and, try to figure out which byte exactly is which and then so on, by playing around and setting the different values and so on. But I don't need that really. So because $SQL optimizer environment is the one which is able to extract data from this binary structure in a human readable form. And again, I don't use the $v because it only shows me the documented parameters. I'm using the underlying $x. So there is a script called SQL opt. The first parameter is what SQL ID I'm interested in. The second parameter is which child numbers I'm interested in. I'm saying that, show me all children. And now the last one is that which parameter values I want to see. Let's say I want to see optimizer index, wherever I have optimizer index. Oops, the cursor was aged out. It was here. You see, it was here, but this query was compiled and it caused this one cursor to be aged out. So let me just for completeness, I just run this once more. Let's see. Just set the different value. Okay, now I have two cursors back. So I have two cursors, child cursors, and of course in real life you may have 20 or 200, or if you hit some bug or fundamental problem, maybe even 20,000, right? So that's a topic for what I actually cover in my class. How to troubleshoot this too many child cursors issues. A little bit of advertising as well into these 2 hours. Okay, so anyway, so so what this script does, it accesses this $x table, and this then Oracle, when you query that $x, Oracle actually goes through library cache. It finds all these SQL IDs, all child cursors, and it extracts these parameter values in a human readable form from this binary structure. And I do see that optimizer index caching is not default. You see, its default is no. So the other parameter is default, so nobody has changed it, right? So that's cool. But the cursor number 0 has this value in, cursor number 1 has this value for this parameter, right? So this actually allows me to kind of complete the picture, sort of, that if I see that there is one session which is running some query and suddenly has compiled a new query plan, then I can query $v SQL opt to see, what is the old value? What are the old values, for example, for the parameters in existing cursors, and what is the value that has changed, in that particular cursor, what my slow session is using. So I can query sesopt. And let's say my slow session is 31, 35, and I know that, hey, this parameter has changed here. It's not default and it's different from the previous. I can just query that and see, see this other session. I think in my case it's not a good example because that session 31, 35, which is here, it's actually not running anything right now. So this particular session 11, where I set the value to 11, is my own one at the moment. But basically, I mean, there are many other reasons why Oracle does not reuse an old cursor and compiles a new one. There are lots of reasons, and non-shared script shows most of them. But if the reason is optimizer mismatch, so if the reason is optimizer mismatch, then it means that there is a difference in some optimizer parameters. And this is when you can query SQL opt to actually see what are the optimizer parameter values in that particular cursor and in the previous cursor, for example, and you compare it with what is the same optimizer parameter in that session which has the problem with sesopt, right? Okay, so so much about that. It is possible to see other sessions parameters, but only these ones which belong to this optimizer environment. At some point of time I will, there is one question from GG. Is setup working with Oracle 9.2? It doesn't work with 9.2, I think. It's 10.2 onwards. I don't think these V dollars or X dollars existed in 9.2. And I think they are not there in 9.1 either. Sorry, in 10.1 either. But maybe they are. I haven't checked that. The oldest version what I have available is 10.2. So the rest is history. Or maybe I'm just too lucky. I haven't had to work with 9i for a while. So there may be some way to use Aura debug to dump the parameters. I'll look into that later, but that would be more hacking already. So and this, when I researched this, one of the things what I was wondering is that are the optimizer environment parameters a subset of all the parameters, right? So let's look into this. So sorry. So these are the system-wide optimizer environment parameters, and these are all, session or the regular Oracle parameters, so to speak. Okay. So, and when I did this, so this is where the parameter name is. I did this. So let's take all the parameters, all the optimizer environment parameters, right? Minus all of these parameters. So this is where the parameter's name is. Select KSPPINM from. So I used minus. So these are all the parameters which are part of optimizer environment, but which are not regular parameters. So basically, I can just do this. Let's take one of the parameters, show parameter optimizer mode hinted. Well, there is no such parameter. Or I can query the $X KSPPI, right? There is no such parameter. So this is what I meant when I wrote about that, the different types of parameters. So actually, there are some optimizer environment parameters which don't have a corresponding, instance parameter. So, some sort of undocumented ones even, and some sort of, so to speak, documented ones. So, for example, when I do this, so I can say alter session set optimizer features enable something, or I could say this: select optimizer features enable. Let's say 10.2.01. I don't know whether it's the valid syntax, so might need some adjustment. But count star from dual. All right. So let's look into this SQL ID, this child number. Let's take any child and say what did we look for? Optimizer. Okay, I think I have the hint in invalid. The hint wasn't recognized. Okay, this is 11G. Starting from 11G, you can see what hints we have, because first we want to validate whether the hint name was correct. So there is $SQL hint in 11G, so 11.1 onwards. So I can query hint optimizer features enable. well, that should be correct. I may need to put this here. Let's see whether that was the issue. Still nothing. So I wonder whether I have done something. I did a little mistake here, so I changed this syntax. So this actually means that when I change the query text, query text changes, then the SQL ID changes as well. So I should run SQL opt on this. Aha. Okay, so let me just go back to this this original query. So the first thing what I did was that I wanted to see whether there are any parameters in the optimizer environment which don't exist as regular parameters. And yes, there are. For example, like some sort of this optimizer features hinted. So, and I just, you see, when I ran a query like this with the correct syntax, let me just run it once more. You see, in a previous example, this was when I used the wrong hint syntax and the wrong hint was ignored. The value was just zeros. But apparently, when I do hint this optimizer features like this, then this hint causes a special parameter in optimizer environment to be set. And CBO probably uses that. So CBO probably checks that if this special parameter in optimizer environment is set, then it ignores the session level optimizer features enable parameter.